welcome to Unit 5, Statistics. Now, stats is a little bit different than some of the algebra that we've been doing recently. It's a lot more of a conceptual grounding, a lot more of analyzing a situation and trying to understand what's going on, interpreting some data, and being able to communicate that out, and a lot less of actually solving for X or crunching a bunch of numbers. There is some numerical pieces to statistics, that's why it's a math topic, obviously, but a lot more of what we're going to be doing is going to be trying to understand how we collect information, how we interpret and analyze it, and then communicate that back out. So let's start out with some vocab. A population. Now, usually when we think of population, you think of what's the population of Byron? Let's say it's 5,000, or the population of the world. Let's say it's 7 billion. We're thinking about a number of people. But in statistics, that's not what we're looking at. We're not looking at number of people. We're looking at who the people is. Which population? For example, if we're doing a study of students at Byron High School, it would be students at Byron High School would be the group. It's who when we're talking about population. Second one, measurement error. It's looking at how you collect data in the real world. You don't magically get numbers that are exactly right. If you use a scale to weigh something, or a ruler to measure the length of something, or maybe a stopwatch to see how fast someone can go, you're going to have error. It's not going to be perfectly exact. So it's basically looking at how much error real data might have and not treating it like these numbers are exactly precise. A survey. We're all familiar with surveys. We've probably taken them online or in person. It's really just a set of questions that people answer. So a survey is used to collect information. Biased data. Well, data is just information. Bias is when that information is not necessarily representing everyone. So when we're talking about bias, we're saying that it does not represent the population we're talking about. For example, if I was going to do a study of high school students and I only talked to ninth graders, that data is going to be biased because it does not represent everyone in the population. It only represents part of that population I'm studying, so there is some bias there. There's other ways of biasing data, such as how you word a question or who responds to the questions you ask. So there's plenty of ways to get biased data. Last thing is a voluntary response. It's the people who choose to respond when you ask a lot of people. So they volunteer. So the volunteer is the key to a voluntary response. For example, on a TV poll, you think of, let's say, The Voice or American Idol. If they do some sort of appeal online to vote, you would have to choose to vote. Not everyone watching the show will vote. So that's what makes it voluntary responses. They tell everyone, hey, you're welcome to join this poll, but only some percentage of the people actually do it. And usually that percentage is fairly low. In the first example, we want to study the 40-yard dash times of high school football players in Minnesota. First question asks, what is the population? And the population is who we're dealing with. It's looking at who we're trying to study. And in this case, who we're trying to study is high school football players, and in particular ones that are in Minnesota. So this whole piece right here, the high school football players in Minnesota, that's our population. That's who we want to study. So when we go on to that next part, how you would collect the data, how would you get information about 40-yard dash times of high school football players in Minnesota? You could, maybe one idea, send out a survey to all players. So all the players submit their information, their 40-yard dash times. Maybe you have a survey to coaches. But if you did that, would everyone participate? Probably not. I think a lot of them might miss the email, and it might not even be easy to find out how to contact all these players. They might not have contact information for every player, so there's a good chance that with this survey, they're going to miss a lot of people. Now, would there be any error or bias in that? Yeah, if you miss a lot of people, maybe you miss all the people that live out in the country, and maybe the people that live out in the country are faster than people that live in the city for whatever reason. Then there might be some bias. So it's hard to know what changes in your data could occur because of who you couldn't reach from your survey. Another thing you could do is maybe when you ask the coaches, you might not be sure if you can trust them. Maybe the coaches are trying to make their players look better in a certain area, and so you're not sure if it's good information. So another thing, let's say you send people to visit a college or visit a high school, and they go to practice and they take some measurements on a few local high schools. Well, unless this person who's going to be doing these visits has a ton of time on their hand to visit everyone, they might only visit some of the schools that are very close together in one of the cities. So again, you're limiting the kind of information you can get. So anytime you're doing real data collection, it's hard to get truly valid data because it takes a lot of time, effort, money to collect from everyone. And if you don't collect from everyone, it's really hard to decide who will you choose to be in your survey. We'll talk more about that in a later section. Next example, we want to study how many times BHS students cheat in a school year. Well, the population is always talking about who. So who, in this case, is going to be the Byron High School students. So again, who is the students at Byron High School? Now, how would you collect information about cheating? That would be really hard to do because if you ask the students, well, they might lie. They might, especially if it's a teacher-given survey, then the student is not very likely to say, "Oh, I cheated 6 times this year." It's very unlikely that someone would admit to it if they did do it. Another thing you could do is ask the teachers, but the teachers might not see everyone who cheats. They also might accuse someone of cheating that really didn't. So unless it's the student really saying that they did it or didn't, it's hard to know for sure. So even the teacher might not have good information. So you have to realize that in certain kinds of questions, like in this case here, the question about cheating, it's really hard to get valid data. There's going to probably be a lot of bias. Most people would probably be more likely to lie and say that they don't cheat. And so the average would probably be less than what it truly is. Last example, 1,200 adult Americans are asked, in light of a huge national deficit, should the government spend additional money to establish a national system of healthcare? This is a question where we have wording bias. And the reason that we have wording bias here is because look at the first part of the survey. In light of the huge national deficit, that doesn't really add anything to clarifying the question. What it does do, though, is it forces you to think in a certain way to say, oh, well, our government is spending too much money. So given that our government spends too much money, is it a good time to establish a national system of health insurance? Well, probably not. But if they started out the question with, given that a number of people are unable to afford health care in our country, should the government spend additional money to establish a national system of health care? Yeah, then that would be something that more people would be likely to say yes to. So the way that you word your question can kind of influence how people respond. Then we're going to just skip down here to questions answered with a number create distributions of quantitative data. Vocab for that is a quantitative distribution, and all that is a list of numbers. So you can see down here, starting at 2, going all the way down, that is a quantitative distribution. Usually it's the kind of thing that if you want to study something, let's say those 40-yard dash times of football players, and you put them all in a big list, that would be a distribution. Or if you give a survey and you say, how much do you enjoy playing basketball from 1 to 5? And you take all the numbers and you put it in a big list, that would be a quantitative distribution. So usually they are the result of a question or a survey. Getting into our example then, you decide to run a contest to see how many free throws out of 25 participants can make. 15 people participate. Here are the results. You have a 2 out of 25, so they didn't do so good. 15, 22, and so forth. And that's how many free throws that each participant made. The list here forms a quantitative distribution. And what we're going to do with that in the upcoming examples is try to learn about, well, where is the middle of that distribution? How far apart are these numbers compared to one another? And do some basic analysis with that data.